Alright, silly people, here's the situation. We have a handful of expressions um, that are like nonlinear combinations of the identity matrix and the poly X matrix. And we need to turn them into linear combinations of the poly X matrix and the identity matrix. Um, so for the first one, you see we're doing the square root of 1 plus I sigma x, uh, which, if you put that into matrix form, looks like 1, I, 1 under a radical. And so um, the way that you want to do this is you first want to factor out a root 2 from the elements of the matrix. And then this is going to become something really big and gross looking. Square root of 2. And then inside the matrix we have 1 divided by square root 2, I over root 2, I over root 2, and 1 over 1 over root 2. The reason I'm doing this is because there's only one value of theta where the cosine of the angle is exactly equal to the sine of the angle, which is what we have to deal with here. And that angle is pi fourths, which has a result of 1 over square root 2 for both sine and cosine. So plugging that, using that, cosine theta over 2, or pi fourths, is equal to sine pi fourths is equal to 1 over square root 2, we can rewrite the matrix as the square root of, I'm going to go ahead and pull out the square root 2, so it's 2 to the 1/4. Then we have the cosine pi fourths, I sine pi fourths, I sine pi fourths, cosine pi fourths. Now this is starting to look a lot like the rotation matrix, so which has this sort of equation which relates it. So it's exp minus I theta over 2 theta hat dot the Pauli vector is equal to cosine theta over 2 plus I sine theta over 2 theta hat dot sigma vector, Pauli vector. So in particular, the version of that where theta hat is just equal to x hat, so you're rotating around the x-axis, you're going to get sigma x in there, and so it's cosine theta over 2 plus I sine theta over 2 sigma x. And then if you use pi over 2 for theta, you get this expression, e to the minus pi over 4 x is cosine pi over 4 plus I sine pi over 4 sigma x, which is exactly equal to the matrix in that radical that we got just now. So we can now rewrite it 1 plus the square root of 1 plus I sigma x as being 2 to the 1/4 times the square root of exp minus I pi over 4 sigma x, right? And then if you take a square root of an exponent right like that, all you're really doing is um, dividing the all you're really doing is dividing whatever's on the inside of the exponent by a half. So you do an exp minus I pi 8 sigma x on the inside there, which you then can expand out into the linear combination of the identity matrix like was requested. So cosine pi 8 plus I sine pi 8 times sigma x. So that's that's the first one. The next one is the inverse of 2 times the identity matrix times or plus sigma x. Um, so putting that in matrix form, you're looking at the inverse of 2, 1, 1, 2. So I'm just going to reduce this using, or I'm going to find the inverse by doing row operations. So 2, 1, 1, 2. If you don't know, you can invert matrices by setting the matrix side by side with the identity matrix, like that. And then perform row operations on both until the matrix on the left turns into the identity matrix. So we'll do row 1, we'll go to 1/2 of row 1. So row 1 over 2, which will give us a matrix which looks like 1, 1/2, 1, 2, 1/2, 0, 0, 1. And then we'll do row 2, we'll go to row 2 minus row 1. So 1, 0, 1/2, 3 halves, 1/2, 0 minus 1/2, 1. And then we're going to have the second row be multiplied by 2 over 3. So you'll get 1, 1/2, 0, 1, 1/2, 0 minus 1/3, 2/3, right? Finally, you'll take row 1 and you'll have it be subtracted by 1/2 of row 2. So you'll get a 1, 0, 0, 1 on the left. And then on the right, you'll have 2/3 minus 1/3 there, minus 1/3 here, 2/3. All right, the left-hand side of that combined matrix is the identity, so we're done. We found that the inverse of 2 plus sigma x was equal to 2/3 minus 1/3 and minus 1/3, 2/3, which you can split up into being 2/3 times the identity matrix minus 1/3 times sigma x. Right. Let's keep going. The last one was just the inverse of the sigma x. So we're going to be doing pretty much the exact same thing, except I think this one's just going to be a bit shorter. So setting it side by side with the identity matrix will look something like this. And then we're going to say row 1 will go to row 1 plus row 2. And you'll get something like 1, 1, 1, 0, 1, 1, 0, 1. Then we'll have row 2 go to row 2 minus row 1. So you'll have 1, 0, 1, minus 1, 1, 1, minus 1, 0. No. Yes, that's it. Then we'll flip the sign of row 2, 0, 1, 1, 1, 1, 0. And we'll have row 1 go to row 1 minus row 2. So you'll get 1, 0, 0, 1. On this side, on the other side, I have 0, 1, 1, 0. Would you look at that? If you take the inverse of the poly X matrix, you get 0, 1, 1, 0, which is just poly X again. So it's its own inverse. Nice.